Our polar equation for a conic section has some assumptions built in, and I want to make sure that we remember what those assumptions are and how we can modify those assumptions. So here's the equation we got, r equals e times d over 1 plus e cosine theta. And this was the situation where, so the focus was at the origin, the positive x direction is going to the right here, and our directrix was a vertical line, x equals d, and this was d units to the right of the focus. Okay. So there are a couple things you might change about this setup, and they give you slightly different equations for your conic section. So one thing you might change is, instead of having your directrix to the right of the focus, you might have it to the left instead, like this. So then x would be minus d. And in that situation, if you run through the whole argument to find the equation for your conic section, again, you get almost the same equation, r equals e times d over 1 minus e cosine theta. So it turns out you just get a negative here instead of a positive. Incidentally, another way to get an equation where the directrix is to the left of the origin instead of to the right is just to allow d to be negative and use the original equation. That also works. Turns out they give you the same thing. So both of these have our directrix being a vertical line. But what if you want your directrix to be a horizontal line? So in that case, you'd have your focus, and your directrix would be the line y equals d. Well, if you work out the geometry of, so here our conic section is going to be something like this, if it happens to be an ellipse. If you work out the geometry of the distance from a point to the focus and to the directrix, like we did for the vertical directrix, you get a very similar equation, r equals e times d over 1 plus e times, and instead of cosine, it turns out to be sine theta in this situation. That's probably no big surprise because, right, cosine is talking about x coordinates, generally speaking, since it's x over a radius, and so our conic section is oriented horizontally, and so if we just switch to sine, our conic section will be oriented vertically instead. So that's the equation of a conic section when the directrix is above the focus. If the directrix is below the focus, still our conic section is going to be oriented vertically, but the equation is slightly different. By analogy with the cosine version, you might be able to guess it. It's e times d over 1 minus e sine theta. Okay, so the general idea here is if you see a sine in your conic section equation, your conic section is oriented vertically. If you see a plus, the directrix is on the positive side of the focus. If you see a minus, the directrix is on the negative side of the focus.